Can you guys hear me now?
Yeah, doctor, yes, can.
Okay, I think because previously I used my headphone, but now I just remove it. So, okay, wait, I just reopen. Okay, so Assalamualaikum and very good evening. So this is what we stopped last week on the line integrals and also surface integrals. Okay. I want to record this one first. Wait, sorry. Okay. Okay, I have problem with my recording, so maybe you guys can record it because if you want to refer to this BBB, okay, I just noticed that our week 4, okay, our recording from week 4 just available starting this week. So if this one week 8, maybe I don't know, maybe at week 12 the video will be available lah. So maybe if you can just record it by using your screen button there, should be okay. I have problems with my recording here. Okay, so this is what we stopped last week on this surface integrals where you have double integral s square integrate respect to s, where s here is the surface of the unit sphere with the row 1. Okay, with the row 1. Or if 2-dimensional, you have circle, we have the radius 1. But 3-dimensional, we call it row 1. So this we already discussed last week, and I asked you to guys try to calculate, okay, the R phi cross product with R theta, whether you guys should get the sine phi there. You guys try this question at your home there? Ada try ke? Guys, dapat tak equivalent to sine phi? Ada, dapat tak? Can you guys get sine phi for the cross product? Ada, boleh kan? You guys should get the same of as given there, and then direct integration by applying the identities of trigonometric. Finally, you have the answer 4 pi over 3. Okay, we also have, okay, now we have this second examples here. Double integral of s, y, z respect to the surface. Here surface is given by the parametric equations. Okay, if the question already mentioned about the parametric equation, so you just straight away use the parametric equation. So here we have s equal to u square, y equal to u sin v, and z equal to u cos v. U given from 0 to 1 and v here from 0 to pi over 2. Answer already given, 5 over 48 plus 1 over 240. Okay, for this question, you can try by using, because you have already the parametric equations here. So that's mean our R, you have the x, y, and z. So for this, it should be u square sine V and also U cos V. Okay, in order to apply the formula of the ds is equivalent to R, because here we use variable U and V. So up to you if you want to differentiate respect to U. So RU, R differentiate respect to U, cross product R differentiate respect to V, and then you find the cross product, the magnitude of it. So this is equivalent to your area lah, area in terms of U and V. Okay. So you need to multiply your R here, respect U. So you should get 2U and then sine V and also cos V. Okay, now differentiate respect to V, you should get 0 lah because we have U square, no V terms here, so it should be 0. Sine V, you should get U cos V, and also cos V, you should get negative U sine V. Okay, so this is the cross product of this the derivative R respect to U, this respect to U, and respect to V. You put it into the matrix lah. Okay, now we want to find RU cross product RV. You put it IJK. So you have the second row here should be your RU, and the third row here is the entry of the RV. Okay, you should get final answer equivalent to 5 square root 5 over 48 plus 1 over 240. Okay, for this question, okay, you can try and test whether you get the same, which is 5 over 5, 5 over 48, 1 over 240. You can try this. Okay, do you have a question until this integrals? Ada soalan tak before we proceed with the next example? Today we are going to cover up to Green's theorem lah. Okay, tak soalan. You can try this. The answer already given. 5 sub 5 over 48, 1 over 20, 240. Okay. So then we have another example. Evaluate the double integral y respect to the surface integral, where s is the surface, z equal x plus y square, and x here from 0 to 1, y here from 0 to 2. Okay, for this question, the difference between this question and the previous question already given to you. What is the parametric form of your example? You have u in the function of xy only, and you have v also in the function of xy only. Okay, not vector lah, just function u and v. But now we already given z x plus y square, so you don't apply this function lah. Okay, you don't apply this. Where this straight away just substitute this ds equivalent to 1 plus differentiate your z here respect x square plus differentiate your z here respect y square root. Okay, this is for the ds. This is your area. So that's mean, okay, what you have here is okay, this is your z, differentiate z respect to x, you only have x, so should be 1, differentiate z respect to y, you should get y. So from here, you should get 1 plus 1 square plus 2y square, and then you get your answer 2 plus 4y square. So this is your ds, and from here, what you should get is, okay, we have double integral y ds. So this is equal to y. Okay, because you just maintain it in the form of xy. So no need to change your y. You just put y. What you need to change, okay, is only the ds part here. You change this ds equivalent to 2 plus 4y squared. Okay, so the A here depend. We have x01, so x0 to 1. Okay, here I want to solve first now because I have variables y. I solve for the variables y. Okay, that is my eraser. So, okay lah, so I put A01 and also 0, 2. So instead of dA here, now it's become dx, dy. Okay? Boleh? So for this case, if you can apply the dot product theorems, where you just split it, you integrate respect to dx. Dx, we don't have any variables, 1. So multiply with y, 2 plus 4y squared. Integrate here respect to y, because you can split your function x and y, where x here 0 to 1, y here 0 to 2. Yeah? Boleh, you can try this question. Okay, you can try this and you should get the answer equivalent to 13 over 2. 13 over 2, 13 square root 2 over 3. Okay, maybe can try whether you get the same answer. And if you notice, you have 2 plus 4y squared. That means you have square inside your square root, and that one is addition. 2 plus 4y squared, you cannot split it, so you need to use substitution. Okay, this one refer back to your calculus. Boleh try this question? Integrate 1 respect to x should be no problem. Integrate your constant. And the second one, integrate y times square root 2 plus 4y squared.
Okay, madam.
Yes.
How do we get zx and zy?
Zx dengan zy. Zx meaning you differentiate your surface function respect to x. So kita ada x plus y square. So you just differentiate x. You differentiate x, you get 1. Right? Okay, for this, we need to apply this formula. We apply remember we have two formula for the surface integrals. Whether the first one or the second one. The difference between the first and second, the second one here, you need to parameterize your function. Okay, you need to parameterize your function, your variables, is because remember we have 3 variables x, y, z. Okay, you have 3 variables, so you need parameterize. It's only 2 variables because it only have 2 variables, 2, okay, respect to your area. So you need to parameterize into just 2 variables, not 3. Okay, that's why in the previous examples, you have 3 variables here, x squared plus y squared plus z squared equal 1. You can split it basically if you want. You have like z. We simplify as x squared, 1 minus x squared minus y squared, positive. Okay, 1, this is surface 1 lah. If you want to just use this function, right? Meaning you don't want to parameterize it. Okay. And the second one, you have z surface 1, is surface 2, z squared. Because we have z power 2 here, we need to simplify it lah. Okay, meaning this is your upper, because you know already, this is basically the sphere with radius 1. If the first one here, z1, basically just the upper hemisphere here. Okay. upper hemisphere here, okay, upper part of your sphere only. Okay, you get answer for your first one here. You add the second answer from your second sphere lah. Here is the below part. Okay, here. You add these two, you get complete sphere. Okay. Boleh. But here also, if you notice, you consider this part also lah. Okay, tak boleh lah. So you need to parameterize your function. Okay, change it into only two variables. Instead of 3 x, y, z, we use 2. Okay, this question also already given alone number 2. Okay, x, y, z, 3 variables. We use only 2 variables. Below. Okay, ada soalan ke sana tu? Okay. And but here we don't parameterize it, right? Basically, you only learn how to parameterize only up to one variable before this. Okay, but here parameter into two variables is difficult lah, not in your syllabus. So if given to you, you can use the function 1. Okay, because function 1 easier for you to understand is function 1. But if not given, you just use the second function here to find your surface integrals. Okay, this example, dia not given to you the parameterized form, so you use the function 2 to integrate your surface integral. Boleh? Ada soalan? Okay, use this function 2, yeah? Apa ni? Yes, which one?
No question.
No question. Okay, Gobina, do you have any questions? Okay, you apply the second function, the ds, which equivalent to square root 1 plus the differentiate z respect x square plus differentiate z respect y square root. Okay. If you notice, this equivalent to the line integral, the previous line integral of the ds. Okay, where we have square root r prime. So do we need to use partial integrate for the y part? Partial, what do you mean partial integrate? So you need to complete your integration for the y. Okay, try dulu, later I show you the integration for this. You have two options, whether you want to integrate it part by parts, meaning you integrate respect to dx, complete your answer, then you proceed integration respect to y, or you can also use the dot product of your integration. Then we have the theorem of the dot product. If you can split your function into two functions, okay, function x and also function y, you can apply the dot product. Here we can split it, so we can apply the dot product. If you cannot split it, don't apply dot product. Direct, you need to read one by one. Okay, try whether you get answer 13 set 2 over 3. Dapat tak? Try lah. 13 set 2 over 3. Later I show you. Answer lah. Okay, try y2 plus 4. Okay, this is the from the previous one. Okay, you can apply the dot product, you integrate respect to x, then multiply, you integrate respect to y, because you can split your function, you can split your x function and also your y function. So here for the x, okay, you integrate 1, you should get x, substitute value 0 to 1, so there should be 1, not just x lah. And then for the y, okay, for the y here, okay, this should be 1 lah. Okay, the answer here should be 1. You substitute the value of x 0 to 1. For the y here, we need to apply substitution. Okay, inside this square root, okay, I use the substitution u equivalent to plus 4y square. So du 8y dy, and also your du is your du over 8y is dy, because we want to change into variables u. Okay, this one also you need to change. So at y0 u is 2, at y2 u is 18. So then you should get this after you substitute everything here. Okay, after you substitute your, after we substitute the y, I just maintain y here. Square root u for 2 plus 4y square become u. This equal to u. Dy you change to du over 8y. So then you can simplify the y. So what you need to integrate is from 2 to 18 square root u over 8 du. Okay, so this you know lah how to solve. Okay, just simple integration. Okay, if you don't know, this is equivalent to, okay, this is basically equivalent to u power 1 over 2 divided by 8 from 2 to 18 integrate respect to u. Okay, I think from here you should know lah how to integrate plus 1 and then times over what you have here. Okay, boleh? Boleh tak this? Okay, so you apply it. Why the limit change? Okay, the limit change because I use variable u. That one corresponds to variable u. Previously, we have variable y. Okay, but I use let u equal 2 plus 4y squared. So that means your y also need to change lah, because that one is the limit for variable y. Because now we use variable u, the limit also must be according to variable u. Okay?
Madam,
Yes?
is the left hand side the 1 dx, right?
1
The one-
dx, okay? Uh-huh.
One comes from the formula, the square root part.
Comes from the square root part.
Formula, which means dz over dx and then plus dz over dy and then plus 1. There's the 1. Is that?
No.
No. Where does
This
the 1?
one, okay, because sekejap beli button ni pening sikit. Kena buka balik. I need to reopen back my slide. Wait. It lost from the share button there. So need to reopen. Okay, so this is the okay, so this is what from the previous question, right? Okay, so basically this is the question lah. After we change all the respective variables, okay, according to here in the surface we only have variable y. Okay, no need to change because here you don't parameterize your function into another variables. Okay, the previous here, okay, previous example, Okay, previous example, you need to substitute this y. Okay, you need to substitute. Okay. Yeah. Okay, you need to substitute your y according to your parametric equation here. Okay. Okay, sorry. Problem. Okay, sorry. Problem with my slide. I don't know what happened here. Okay, previously you need to substitute your y and z here according to your parametric function lah. Okay, your example y here, we have u sine v. So that's why you need to substitute here. Y here, u sine v, z here. What is the z? U cos v. Okay, substitute. And then the ds here, you need to change it according to this ds. Okay, but now we have another example where you don't parameterize your function. Okay, you don't parameterize your function. Okay, here you have y ds. Since you don't parameterize your function, your ds here, you need to apply this formula. Okay, the square root 1 plus z, differentiate your surface function here, differentiate respect x. Here, that's why we get 1. Your surface function, differentiate respect y, you get 2y. Okay, after you substitute everything here, your y ds, just substitute this ds, you should get this one lah. Okay, double integral y ds, you should get this. Okay, from here, you notice this is the basically, remember previously we have the formula, we have this from the double integral formula. If you have like function x, okay, and then you have function g for the y, dx dy, where here must be number lah. Okay, here should be b, okay, a, b, and then c, d. From the previous theorem or definition, this can be split into two, where you can integrate your dx, ds here just function x lah. Okay, because you can split your function f(x), one function, and then y function, another function of y. So you can split it according to like this lah. Okay, if you refer to this question, okay, after you substitute according to this question, you see here, you can split your y, you can split your x. If you don't want to split, also okay. Okay, kalau you confused pasal ni, saya just rewrite back the solution lah. So that is not in the, you don't split it. Boleh, I just reapply the formula. Okay, kalau you don't want to like change it according to the formula, okay, what you can do from here, okay, sekejap just select, later I answer your question. So this one you can just solve it, later you answer you just want from this answer, multiply, answer from this part, so you should get as given is 178, is from previous one. You should get 13 sec 2 over 3. Okay, you should get 13 sec 2 over 8. Okay, this is if you split lah. Okay, now you don't want to split kan? Okay, you don't want to split, so I back to the previous question lah. Okay, sekejap, saya kena ambil balik lah. This is the question. Okay, if you don't want to split, previously what we have is, it should be 0 to 2, 0 to 1, y, 2 plus 4y squared dy dx. So this is the question, right, previously? If you don't want to apply the dot product theorem. So basically this is your questions. In point form, boleh saja. Okay, if you don't want to apply the dot product, you integrate this one part by part. So here we integrate respect to y. Okay, you just need to solve this part first. Okay, same like the previous one, you need to assume let u equal 2 plus 4y squared. So you do the rest lah. until you get the answer dy. Okay, example here you get answer is a, then you integrate your a here respect to x from 0 to 1. So you still get the same answer, 13 square root 2 over 3. Boleh? Okay, up to you whether you want to split it or you don't want to split your function into two. But just make sure you know what type of function that you can split, what type of function that you cannot split. Don't just simply split your function. Cannot, it depends on our function also lah. Okay, question. Okay, the Amanda Nora already solved. Okay, the limit change according to your assumption lah. If you use substitution, meaning your limit also need to change. Okay, if you use substitution only. This said here, doctor, for the limit change is only applied in this case or for every integration. Okay, limit change only if you use substitution technique. Remember, integration we have like, if you have limits for your integrals, that one depend on your function, and it also change if you use substitution. But if example you use integration by parts, because we only have like two techniques, right, to integrate, whether substitution or by parts. If by parts, no need to change the integral limit lah. Okay, only for substitution you need to use the limits according to the new variable that you use. Boleh, so the answer is 13 square root 2 over 3. You can apply, you should get the same answer. Okay, you try lah, sebab this one basically just a calculus that you already learned previously. Okay, here I split, for this one I split lah, I split, I use the dot product, but here I integrate part by part. Okay, integrate part by part. Okay, where I integrate respect to y and then I proceed here with the dx. Still you get the same answer. So jangan confuse. Example cannot split, so I just give example but I don't solve lah. Example yang you tak boleh split, okay, is maybe example x plus y. Integrate respect x, integrate respect y. Okay, this one cannot split. Okay, this one you cannot split. Okay, because remember the function that you can split is only, okay, this one cannot split. Yang you boleh split, example you ada function x and you ada function y. Okay, product between function x and function y. Here plus, right, so you cannot split. Okay, you cannot split. This one, only this part yang you boleh split, dx, dy. And here also should be number lah. Maybe x from a to b, y from c to d. If this limits also in the form of function, ingat tak kita belajar function, also cannot split. Boleh, this one refer back yang sebelum ni. Decimal boleh. Okay, you can put your answer in the decimal form. Should be okay. Yeah? Boleh guys?
So if the function can be split, the function must be multiplication, madam.
Multiplication between your function x and your function y, and make sure your limits also must be only numbers. Okay, remember ini your punya region tu rectangular region lah.
Only numbers and multiplication function only. Okay, thank you, madam.
Yeah. If you dapat the variable limit, tak boleh juga guna this split lah. Okay, so still I need to reopen my PowerPoint. Sekejap ya. I need to reopen back my PowerPoint slide. Okay, this last example, another example that you can try on this surface integrals. Okay, I don't want to go deep on this surface because we still have got to cover about this integrals. Okay, these examples, S is a part of the plane z1 plus 2x plus 3y. Same here, already given the z, the plane. So no need for you to parameterize it. Because if you, for the surface integral, make sure your parameterization should be into variables. So we don't learn about that part. That lies above the rectangle. So this rectangle, okay, you boleh try and you check whether this question you can use split or you cannot use split. Okay, the answer is 175 square root 14. Kalau limit tak tukar boleh, it should be okay. If you don't want to change the limit, meaning after you integrate, you put everything back in the form of y, should be okay. Okay, so no need to change your limit of the integral. You boleh guna the value y from 0 to 2, should be okay. Okay, this is another example. Maybe you can try. Okay, later to test your knowledge. Answer is 171 square root 14. So I just give you the hint here. This one cannot split. You need to integrate one by one lah. Okay, whether you integrate respect to x first or you integrate respect to y, up to you. Because our limits of x and y numbers 0 to 3 for x, 0 to 2 for y. Okay, this one you can try lah. Okay, to get answer 171 square root 14. Mungkin boleh try dulu. Check whether you get the answer 171 square root 14. Okay, try here. Try this question lah for maybe up to 650. Okay, try up to 650 and then take your break for 5 minutes. Then we start back at 655 lah. Boleh? Now, 10 minutes to try and also to take break. Okay. Okay, for the previous question, it just give you 0, 3 times 0, 2. So that's mean xy lah. X dulu 0, 3 and then proceed by y 0, 2.
Madam, madam,
Yes.
how did we get the limit the x for the s and y?
Given by the question as already, because the question, okay, but I show you back. You have the slide. It's given already 0, 3 and 0, 2. That means x from 0 to 3, y 0 to 2.
Okay.
In the question, you ada soalan dia kan?
Yes, yes, madam. But 0, 3 and 0, 2, right?
0, 3, you follow the sequence lah. It should be x, y, z. So x first and then proceed by y.
Okay, okay. Thank you, madam.
Okay, because that one already in simplified form lah. Okay, kalau dia tak bagi, basically they give you lah. We make it clear for you which one is the x and which one is the y.
Doktor,
Yeah.
kenapa x squared y times dengan 1 dia jadi x squared?
Yang mana
Yang dekat line third line dengan fourth line.
Yes, betul. Saya miss the y. So you put back lah the y. X square y times y, it should be xy.
Okay.
So I miss the y here. Okay, you put back here y. Okay, so here we should have y. So y square over. Okay, no, not yet. Integrate. Okay, then you proceed with your integration. Answer is 171 square root 14. Okay, so later you discuss further in your tutorials. Okay, next week we have tutorial. You discuss lagi lah, but tutorials. This integrals. It might be in your test 2 later because our test 1 only cover up to line integral. Okay, so we proceed with the line integral, but for the closed region. Previously, open region. Okay, can I proceed? Boleh kan? Amara, this is the question lah that you asked. X square y z, the previous one, the line integral.
Oh yeah, madam. How? I mean, because the 0, 3. How are we going to determine S and Y? I forgot already.
Okay, because we follow the sequence lah, X, Y, Z. So yang first integral tu should represent X, the second integral tu should represent Y. Okay.
Oh, so cannot be opposite.
Kena lah opposite, mana boleh Y, Z. Y, X, you kena X, Y, Z. Okay.
X, Y. Okay.
In standard, kita akan put X dulu and then proceed by Y. Okay.
Because the square bracket confuses me.
It's just because it doesn't mention, right? But basically we follow the sequence X, Y. So X03, Y02.
Okay. Thank you, madam.
Okay. So so I proceed with what we are going to cover. We proceed lah with our content. So we have here Green's theorem. So what is Green's theorem? So now this is basically the last three parts, not chapter, parts of your chapter 2, still chapter 2. Okay, this is part of the line integrals. Okay, previously you learned already about the line integral. Remember we have like line. Okay, if you have like this region, okay, you need to parameterize it in the form of T. Kalau ingat lagi lah. Okay, you have the X component, you also have the Y component. The Green's theorem is part of this, but it for the closed region. Okay, and it should be counterclockwise direction. Okay, counterclockwise direction. Then you apply the Green's theorem. This one. Okay. So, what is the Green's theorem? Tak perlu. Okay, is the Green's theorem. Let R be a simply connected plane region where boundary is simple and closed. It should be closed and simple, meaning it's just a simple function lah. We don't want the complicated function where you can get the boundary of your function, and should be smooth also, oriented counterclockwise. Let F and G be continuous and have continuous first derivative partial on some open set. This one just the definition. Okay, if you notice this from what we already covered in line integral, then the F, okay, here, F dot dr, we already covered this in previous line integrals. But if you notice, we have this circle here. Okay, this circle meaning your curve is closed curve. Okay, not open, it should be closed. Then this Green's theorem said that this dot product F and dr, where you also have here, this one also equivalent to work done. So if you refer to the slide used in you learn, it also give example work done. So it's the same. Is Fx, this is the work done, F dx plus G dy, it equivalent to double integrals of your region R. Okay, differentiate your G, this is our G. Okay, how to know which one is F, which one is G, because both function x, y. G is where you have the dy, so this should be your G. Okay, and the one with the x dx is your F. Is equivalent to double integrals of your region R, your closed region here. Differentiate G respect x minus differentiate F respect y. Okay, so you alternate lah. G here should be differentiate respect X minus this F differentiate respect Y. Okay, then you just integrate respect to the region R here. Okay, examples. Evaluate the line integral below where you have y squared dx plus x squared dy, where c is the square with vertices 0, 0, 1, 0, 0, 1, and 1, 1. Okay, that's mean from 0, 0, you go to 1, 0. Okay, so you have curve 1. From 1, 0, you go to 1, 1. So you have curve 2. And then from 1, 1, you go to 0, 1, you have curve 3. And then from 0, 1, you go back to 0, 0. So it becomes closed curve. Previously, if piecewise like this, you need to like solve for curve 1, your y squared dx plus x squared dy plus answer for curve 2, the same function. Remember this one piecewise, so you need to like, since you have 4 different curves, you need to solve for line integrals lah, okay? And then lastly, you have curve 4, y squared dx plus x squared dy. This is what we previously covered on the line integrals, where, okay, if you ingat lagi lah, ya Allah, dekat ni. Okay, where if you still remember your R here, because here is your curve 1, because the y maintain at 0, but my x change from 0 to 1. So I can put t and 0. Okay, for this lah, where the t for this change from 0 to 1. Kan, because our x change from 0 to 1. For this curve 2, I can put the r. Okay, this is R1 lah, this is R1. For this curve 2, what change is the y? So here my R2 is equal to 1 and also t. Okay. Not this one, not confused but okay, not okay. Okay. Okay, where there is the curve 2, where the t here change, for curve 2 change from 0 to 1. For curve 3, if you notice what change is your t also, but your t, okay, this one R3, okay, the x change, so I can put as t, y remain as 1. So, but t here, it from 1 to negative to 0, so 1 to 0. And for curve 4, the R is x maintained at 0, but y change t, but t here from 1 to 0. Okay, so you change lah your curve 1 here and your dy dx here according to your R. Ingat lagi for this question? Okay, that one what we covered previously. Okay, then you kena add up all your answer from C1, C2, C3 up to C4. Okay, you have 4 curves, so 4 different R. Yes, Gobi? Okay, and then you put everything there, your answer should be 0. Okay, boleh the first one tu? For question A. Okay, that one sebelum ni. But now, since we can apply the Green's theorem because our region here closed region, so you can just directly apply the Green's theorem. Okay, what is the Green's theorem for this? Okay, if Green's theorem, because here you have this circle meaning closed region, Green's theorem, okay, f dx plus g dy of your dy equivalent to double integrals of your differentiate g respect x minus differentiate f respect y, and then your area. Okay. Okay, now if you look back to our area previously, close, this is our x, this is our y. You just substitute here. Gx meaning your g here. Okay, this is your f dx plus g dy. So that means f is y square, g is x square. Okay, so your differentiate g respect x, you should get 2x minus differentiate f respect y, you get 2y. Okay, because here rectangular, so you can integrate respect x or respect y first, up to you. Here I use dx dy. Since the limit for x from 0 to 1, so x 0 to 1, y also from 0 to 1, so y also 0 to 1. So you apply Green's theorem, here integrate respect to x, you dapat x square minus 2xy, 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 0 to 1, so you akan dapat answer lah 1 minus 2y, and then integrate this 1 minus 2y respect to y, you get the answer y minus y square 0 to 1, so answer is 0. Boleh, this one if you apply the Green's theorem. Okay, if you apply the Green's theorem, you need to know which one is your f and which one is your g. Function f is the one with the dx, function g is the one with the dy. Boleh, so Green's theorem basically part of line integral but for the closed curve, okay, closed region, and it should be in the counterclockwise direction. Ada soalan for Green's? Green's quite easy lah, it just substitute into the formula. Ada soalan kah? Tak ada. If no, maybe you can try this example. Okay, evaluate by Green's theorem, x4 dx plus xy dy, where C is bounded by triangle with vertices 0, 0, 1, 0, 0, 1. Okay, solution. Yeah, it's already given there. But you try, make sure, because here basically we don't give you the limit of your integrals, you need to define it. Okay. This is for the triangle, but here close, so you can apply the Green's theorem. No need for you to piecewise it into curve 1, curve 2 and curve 3. Here should be 3 curve lah if you want to apply the previous line integral. Kalau close region, it should be closed. It bounded. Okay, kalau open region, dia open. Example, right? Previously kita ada like this and this. Okay, kalau you punya test pun it open, right? Like this example. So you ada curve 1, you ada curve 2. So it open. This one open sebab dia not bounded. Kalau bounded, it should be like this. X, Y. It should be, it bounded lah. So it become close. So this one close. Okay. Kalau open meaning your region tu open region. So you can apply Green's theorem. Okay. If close meaning your starting point and also your end point should be the same point. It should be the same point. It close region. Okay, sebab if you refer the integral also dekat C tu dia ada like circle. That is close region. Because the circle meaning close region. Okay, for this question, maybe you can try generate your line there. Okay, and you should get the answer is 1/6. Okay, this question. Dapat kan? Okay, before I forget, your test 2 is on week 10, Friday. Friday week 10. Okay, Friday week 10. Friday ke? Sorry. Kawan-kawan. Is 10. 10 is Monday. Monday. August. So your test is on 8 August. 8 August berapa? Saturday lah. Still Saturday. Okay, so boleh kan this question where you have X and also X4 for your G and here answer already given, but for this question, okay, you need to apply f dx minus g. Okay, it should be minus. If here you have minus, example minus, meaning all of this, meaning your g is it plus. If you have minus, meaning this entire negative xy should be the dy. Okay, refer to your function lah. Okay, refer to our function. So for this is your f, okay, because f dx plus g dy, sorry, only one. Okay, that's mean your f is x4, need to differentiate f respect to y, which is 0. Your g is xy, need to differentiate g respect to x, which is equivalent to y. Okay, then you put into the formula, which is dg x differentiate g minus differentiate f respect x of your area. So G X is Y minus 0. Okay, since this is your line, okay, your region D. Okay, here Y. So here if you use Y, we need to integrate respect to Y first. Since Y, okay, this one refer back to double integral. The direction should be upper and lower boundary. If you refer here, upper is this curve. So this curve is 1 minus x. So y equal 1 minus x. Lower is all this horizontal line. So this is y equals 0. Then proceed with dx. X here just take the number from 0 to 1. So 0 to 1. Okay, that's why we learned about this double integral before. So you can apply it into this Green's theorem. Okay, ada soalan for this?
Madam, is the equation given? The y equal 1 minus x.
That one you need to find it lah, because if you notice in the question it just mentioned the vertices 0, 0, 1, 0, 0, 1. So you need to find your y function lah.
Our own. Okay.
You also can solve your x function, meaning your x should be 1 minus y. Okay?
Okay. Thank you, madam.
So is f x4 because in the equation x4? No, it's okay. You need to follow this formula, the Green's theorem. Okay, if you notice here, the one with the x here is the f. Okay, if the question maybe dia tukar, dia letak 2xy dy plus x cube dx. Meaning this should be your f, this should be your g. It depends on this dy dx. Okay, and also it should be plus. Kalau soalan dia tukar, pernah one time we just change the formula lah. We just change example. We put 2xy dx minus 3 dy. Meaning this entire negative 3 should be your g. Okay, include the negative because the formula should be positive g. Okay, that's how you differentiate which one is your f and which one is function g. Okay, it depends on the what with the dx and what with the dy. Okay, so we have another example. Okay, where remember previously I mentioned to you if anything related to circle, maybe you not cover, but if anything related to circle, please rewrite it in the form of x equal r cos theta, y equal r sin theta. Okay, that one for circle. Okay, example for this question. Okay, if you look at the functions, it's quite horror lah to see here. You ada 3y exponent sin s integrate respect to dx, and then you have 7x plus y power 4 plus 1 square root, which is basically impossible for us to integrate y power 4 plus 1 square root. Okay, because remember if you use substitution, it must cancel some variables there. But here y4 plus 1 impossible to cancel because we need at least y power 3 to cancel it. But here we don't have any y power 3 to cancel it. Okay, for this question, they just give you difficult function. But basically just apply the Green's theorem, no need to apply the line integral. It should become simple. Okay, so evaluate by the Green's theorem. 3y minus exponent sin dx plus 7x plus y4 plus 1 dy, where c is the circle. Okay, where c is the circle. Okay, if C circle, meaning your closed curve is a circle with a radius 3, radius 3. Okay, so with the dx, this is the f, with the dy, this is the g. So for f, you need to differentiate it. Okay, remember, f need to differentiate it respect to y. So 3y, you get just number 3. Okay, and our g is our g, 7x plus 7x plus 7x plus okay, y power 4 plus 1 square root, but g need to differentiate respect to x, so we only have 7x, differentiate we get 7. So finally apply it, differentiate g respect x minus differentiate f respect y. So what you have is 7 minus 3, which is equal to 4. Okay, so you put 4 dx dy, but okay, this is circle. If you want to put it in like what we call it in x and y form, okay, x and y form, here I use x, okay, saya tukar lah, I use y here instead of x. Okay, because we're familiar with dy dx. So my upper boundary for y should be 9 minus x square root negative, and the lower bound positive, sorry, and the lower boundary is negative 9 minus x square root. Okay, this upper and this lower boundary. Okay, so you need to put it y 9 minus x square root, and here negative 9 minus x square root. Okay, you have negative here. And then for the x, just take the number from negative 3 to 3. So this is the function that you need to integrate. Okay, you need to integrate, but if you integrate here, you tak boleh solve. Okay, we cannot solve it. Basically, you tak boleh solve. You boleh try. Okay, kalau you try, you akan dapat 4y, you put the y, what you get later is 9 minus x square root, minus, it become plus, so you get 2, 9 minus x square dx, integrate from negative 3 to 3. Okay, after you integrate respect to x, you kena apply apa formula ya? Tangent lah, semua tangent tu. Boleh buat difficult. Okay. So what you can use here, kalau you refer dekat lecture notes slide pun, you ada this one example where you translate into R. Nanti confuse kenapa ada R kat sana. Okay. Why? Because remember, you only have in terms of number only if you have rectangular region, but now you ada circle, so it is not rectangular. So your limit should be in the form of function, okay, in the xy axis. Okay. Okay, so you have this 2, 9 minus x square. So you integrate this 9 minus x square. You ada belajar ke arcsine arctangent? Saya pun ingat ini. Arcsine arctangent. Notice we change it in the form of, okay, saya dah check. We don't have any integrals for square root 9 minus x squared. Tak ada. Yang ada only 1 over square root for a constant minus x squared. So, how to solve this? if you refer to this slide, you ada R. Instead of you use XY, you change it in the form of R and theta. So what the meaning of R and theta? Here we change it to the other variables. This one kita tak cover previously, but kalau you ingat lagi, last time I show you for the sphere, kita ada X, Y, Z, but then we change it into the rho, theta and phi. Okay, it's the same. For circle, when you want to change it, you need to apply. Okay, okay, it's the same. Kalau you ada, okay, previously you learn about sphere. Okay, about sphere from x square plus y square plus z square equal to rho square. So you ada x equal to rho square yang ni. Y, what is the rho? Z, what is the rho? So lupa this information, I forget already, but you can refer to your previous slide. It's the same. Untuk circle, we know already. Okay, you have this circle. Your x is r cos theta. Your y is r sin theta, and meaning you change it, instead of you guna variables xy, you guna variables r theta, and you also need to change this. If you have dx dy, when you want to change your variables into r and theta, you kena letak r, this one depend lah, dr d theta. Okay, so what you need to add here, what you need to put here is you need to put the variables r. Okay, you have this variable r. We call it change of variables. We not cover it, but in our example, sometimes you need to change it into the variables r. And every time you change to variable r, you kena make sure instead of dx dy, you letak r dr d theta. Boleh? Boleh kan? Okay? Okay, I think we take a break lah for 10 minutes first. Okay, we break for 10 minutes. Later we go back to the previous examples. Okay. Okay, so since here we have here some notes that every time you want to change, instead of you use your variables x, y, okay, remember this one not parameterization. This one we only change, instead you use x, y, you need to use r theta, meaning two variables, still two variables. Okay, parameterize meaning you tukar instead of x, y, you gonna t, so change to one variable. Or before this x, y, z, you change into two variables. That one is parameterization. But now instead of you use x, y, you use polar coordinates. Meaning you tukar the variables instead of x, y, you guna polar coordinates. Same as substitution lah, but here we call the coordinates. Where every time you change we call the rectangular coordinates for your x, y. If you want to use r and theta, meaning you use your radius and also your angle, you need to put r there. Okay, instead of just dr d theta, you need to multiply your function with r. Okay, this is where we change your coordinate system. So from here, sometimes you need to change your coordinate system because your region cannot be translated into the variables lah. Okay, but we don't go deeper on that part. So I've already put here. Okay, so r, x should be r cos theta, y should be r sin theta. This one fixed. Where r square equivalent to x square plus y square from the circle properties, and the theta here, tangent theta is y over x. Okay, meaning instead of you use x, y variables, now you use r and theta variables. Okay, because x r cos theta, y r sin theta, so r and theta. And you need to change this dA now with r dr d theta. Okay, you need to put it. Okay, now back to our previous examples. Okay, yang ni tadi. This one you cannot integrate, obviously you cannot. You need to use numerical method to integrate this. Okay, but we don't cover numerical method yet. This one later in your EM2. Okay, so but here you can basically you change your function here. Instead of you use y and x, how about you use r and theta? Because we know r and theta related to circle. And our region here also related to circle. Okay, remember this Green's theorem, it should be bounded region, right? And this basically, previous examples, okay, you need to this boundary basically represent your bounded region lah, your shaded, it should be shaded your region here. Not just the line, but it should be the bounded region here. Okay, so same here. If line integral meaning the line, but green here you can consider also the region inside here because remember double integral meaning area, right? So the area for this circle, that's why here the upper and lower we have two limits here, so it becomes the closed and shaded here, meaning inside the circle. If you apply because it should be closed like this. So from here we know already our r is the radius. Because this is I just draw it here. It from, radius start from 0, right? So it's 0 until the boundary of your circle. You have this closed circle. Okay, so this is our r lah. So that's why the limit for r here should be from 0 to 3. And also the theta here is your angle. Complete circle, it should be from 0 until 2 pi. Okay, that's why here, instead of you use x, y, now you have 4 is the same, but your dx, dy here, you change it to r, dr, d, theta, and dr, d, theta, just refer back to your region, circle, r from 0 to 3, your radius, and theta from 0 until 2 pi because closed circle. Boleh for this question. So you dah direct integrate it. Here you boleh apply your split because here you can split r dengan theta. So you can integrate. Basically you can just integrate your 1 d theta, integrate your 4r dr. You boleh split lah. Okay, so your theta from 0 until 2 pi, your r 0 until 3. You can split, you still get the same answer, which is 36. Okay, guys, for this, bila you ada circle as part of your region. Okay, so this is how we get the r, no need for you to understand. And this is another example. Maybe you can try. The answer must be equal to 0. Okay, you try it. Okay, answer should be 0. Yes, if you have circle, you guna this, we call it polar coordinate system lah. You guna R and theta. Okay. Kalau you refer the slide in your, you learn also, we have this one example. So if you like wondering why you have the R there, because every time you tukar dx dy kepada R theta, you kena multiply with R. Okay, so for this example, you boleh try. Okay, because we don't have enough time, I just show you the answer. Okay, so with the dx, you know already, with the dx is your f, and with the dy is our g. F need to differentiate respect to y. So here our f basically x e negative to x, no variable y. Differentiate y, you should get 0. And your g is x4, okay, this is our g, x4 plus 2x square y square. G need to differentiate respect to x. So you should have 4x cubed plus 4xy square. Okay. And from here, you put lah it dg dx minus differentiate f y. So what you should get from here is 4x cubed plus 4xy square. Because this is part of the circle, you change it into function of r and theta. And we know already that x square plus y square equal to r square. So this function can be put as 4x x square plus y square, which is in the r theta form is, we know also that x is r cos theta. So now you put lah 4 r cos theta, and this x square plus y square equivalent to r square. So this is the function that you need to integrate. You put in your double integrals, it 4r cube lah cos theta, and make sure to multiply with r. Okay, so what is now the limit for your r and also your theta? Theta, because you notice here complete circle, so 0 until 2 pi, but it said between these two circles only. So this is your region lah. So from here you know your r from 1 to 2. Okay, both numbers, so you can, up to you lah, you can put dr d theta or d theta dr. So r 1 to 2, theta 0 until 2 pi. Here also I can split if I want, because r cube multiply cos theta. I can split lah, I solve r cube, and then I also integrate the cos theta. Then it's up to the respective values. Okay, answer equivalent to 0. Boleh? This example, every time you ada region related to circle, you can use r and theta. Okay. So you now, if you refer back to slide in your you learn, you boleh like solve it lah for the vector coordinates, vector calculus part. Okay, so I think that's all. Okay. Why are power of 3? Because kita ada 4x cubed plus 4xy square. I factoring out the 4x. So I have x square plus y square kan. So x square plus y square is r square. Okay, Farisha, later we go back to this slide. So please make sure you sign your attendance, and also please also do the cost satisfaction survey lah, but use in the one in the ULearn. Okay, you go to the next, we have the satisfaction pool for you to complete. Okay, and attendance prefer power apps lah. Okay, if you have question, you can stay. If no question, you can dismiss. See you on Wednesday.
Thank you, Doctor.
Okay, sama.
Thank you, Doctor.
Okay, sama. Okay, you're welcome. Another questions? Kah? Markah sabar, saya baru marking number 1. Banyak, baru lepas sorting, banyak dah sorting. Your test previously ada 3 set, so 3 different question lah. Okay, ada soalan kah? Will this slide be on ULearn? Later I will put the slide about the Green's theorem lah. Okay, you can check it later. But I think I already put there. I already put in your ULearn lah. Baru lagi saya letak at 6 PM tadi. Okay, any other questions? Kalau tak ada, I want to end this meeting. Okay. Tak ada ya? Alright, so thank you guys.